Hello friends, Agrawal is Assistant Professor in Civil Engineering Department, Sandipani Technical Campus, Lect. Today's topic is derive expression for slope at support and deflection at center of simply supported beam subjected to concentrated load at center by Macauly's method. Learning outcomes. After watching this video, student will be able to understand the concept of Macauly's method, and also student will be able to find the slope and deflection of determinate structures. So now here we take here the simply supported beam, and this beam is subjected to W concentrated load at center. This is L by 2 and this also the L by 2. This is A and this is the B. So our aim is to find slope at support and deflection at center. This total is L. And this is L by 2. So now we know by the symmetry of diagram, this RA is equal to W by 2 and RB is equal to W by 2. So we have to use here the differential equation of the elastic curve, that is d2EI d2y by dx square is equal to the mx, where mx is the bending moment of the beam. So for the Macauly's method you have to make the section. So here's the force is W by 2 and here W. So make here one section. Section 1 1 and this is the x. So we have to write the bending moment equation mx is equal to, for first section, that is W by 2 is create the sagging bending moment, so the positive W by 2 into the x. Then here the section is complete. Then make the second section here. This section 2 2. So for section 2 2 is again the x here. Now for section 2 2 this force is over. So what is the remaining is this force is W. So this force is create the hogging moment, that is why is minus W into this distance. We know this total is the x and this is the L by 2. So this becomes x minus L by 2. Then EI d2y by dx square is equal to this W by 2 into x. Then this is partition for first section. Then the second section L by 2. So by the process here we have to integrate first. So integration both sides. So this becomes here EI dy by dx is equal to, here is W by 2 is already here. Integration of x is x square by 2. Here plus add here the constant of integration, the C1. Then move to the second section here, minus W, we know by Macauly method, integration of this x minus L by 2 is the bracket square by 2. So this is the slope equation. This is the slope equation. Then again integrate this equation. So again integrate both sides. So here this becomes EI y is equal to, now this is W by 4. So this is W by 4. Then here integration of x square is x cube by 3 plus integration of this C1 is C1 into the x. Again here add one constant of integration, then minus W x minus L by 2. This integration is x minus L by 2 bracket cube divided by 3. So 3 into 2, that becomes the 6. So here we write this equation EIY is equal to W x cube divided by the 12 plus C1x plus C2 minus W x minus L by 2 bracket cube divided by 6. Now here apply the boundary conditions. So which are the boundary conditions? We know that when x is equal to 0 at here, this, when x is equal to 0, the y is equal to the 0. Also add this b, x is equal to the L, so y is equal to the 0. So we have to apply these two conditions to find the C1 and the C2. So when x boundary conditions, x is equal to 0, so y is equal to 0. So put in equation number 2. This is our equation number 2. And the previous one, this is our equation number 1. So put in equation number 2, because this is the equation of y. That is why I have to put the value here. So when x equal to 0, it means this first section, the first section is limited up to the x is equal to the L by 2. This section is limited from this 0 to x equal to 0 to x equal to the L by 2. And beyond this, here is L by 2 to the L. This is the second section. So this is x equal to 0, y equal to 0. It means we have to use only the first section. So put here 0 into this equation. This becomes 0 is equal to here the 0 plus the C1 into 0 plus the C2. So we can say that C2 is equal to 0. So in this way we got the value of the C2. That is C2 is equal to 0. Now next apply the condition, boundary condition. When x is equal to L, so y is equal to 0. Again put this in equation number 2. Equation number 2. So equation number 2 is this. So here we have to put the x equal to the L. So this y becomes the 0. So this value is 0. So 0 is equal to, now here x equal to L. So W L cube divided by the 12 plus C1 into L plus C2 is 0, then minus, here this value is the L, that is why we have to use the full section, first section and the second section. So W in bracket L minus the L by 2 bracket cube divided by the 6. So 0 is equal to WL cube by 12 plus C1L minus W, now here, into L minus L by 2 is the L by 2. So L by 2 raised to power 3. So L cube divided by the, or we can say that here in this way, L by 2 raised to power 3 divided by 6. So again simplify this. 0 is equal to WL cube by 12 plus the C1L minus, this becomes WL cube by the 48. So C1L is equal to, this is toward left side, that becomes the WL cube by 48 minus the WL cube by the 12. So here if we solve this, so we got here the C1 is equal to minus WL square by the 16. So in this way we got the value of C1 and C2. So C2 is equal to 0 and C1 is equal to minus WL square by 16. So now our aim is to find the slope at A. The slope at A. So we know the slope equation. What is the slope equation here? Is EI dy by dx is equal to Wx square by the 12 and x square by the, is how much? Wx square by the 4 by the 4 plus the C1 x in section minus W in bracket x minus L by 2 bracket square divided by 2. This is the slope equation. So now here for the slope at A, so we have to use here the first section only, because when x is equal to the 0, so this dy by dx is become the IA. When x equal to 0, when you put this value of x equal to 0, this dy by dx becomes the IA. So we can say that here EI IA is equal to this W into the 0 divided by 4. Then here we know the value of C1 is minus WL square by the 16. Then here we know this is not equal to the x. So we can say that here EI IA is equal to 0 minus WL square by the 16. So IA, we can say that is here. IA is equal to minus WL square by the 16. Yeah. Now this value is a negative, it means is a clockwise. Negative means the clockwise. So we got here the slope minus W square upon 60 EI. The next is deflection at center. So next part is the deflection at the center. So here in the deflection equation is EI y is equal to WXQ divided by the 12 plus C1x plus the C2 minus W into x minus L by 2 bracket cube divided by 6. This is the equation. So now deflection at center, it means we have to put the value of the only the x. So what is the value of x? The x is equal to, here we know, we want deflection at center means x equal to the L by 2. So x is equal to the L by 2, this y become the yc. Suppose this is a c, this point is a c, so this y become the yc, this point is the c. So EI by C is equal to W by 12, here in bracket is L by 2 bracket cube, then minus, here C1 value is minus WL square by 16 into x is equal to L by 2, then C2 is 0. Now here this value is x equal to L by 2, it means we have to use only the first section, not the second. If you put the value of L by 2 here, so automatically L by 2 minus L by 2 is the 0. So only consider the first section. Then EIYC is equal to, this is WL cube by 96 minus the WL cube by the 32. So EIYC is equal to, this becomes minus WL cube by the 48. So YC is equal to minus WL cube by 48 EI. And this negative value, negative indicates downward deflection. So this is the answer. The deflection at center is WL cube by 48 EI, and the slope is the WL square upon the 16 EI. Thank you.